Hello, how's it going? It was the weirdest hello I've ever said in my life. It was like sounded like I had an accent or something. Welcome back, everyone. I figured I would upload a digital version of this before the talk actually happens live. This is one of the two talks I'm giving at WaffleCon 6. I hope to see some of you guys there. But for those who can't make it, this is Aggregate and Holistic Prototype Development. We're going to be making reusable games. And that's kind of what we're talking about, is how I turned parts of my games, like player controllers or generation systems, those are the two examples in this talk, into reusable tools that can be used in different ways. So yeah, we're going to be discussing turning prototypes into reusable tools, what single-use responsibility principle is and why it's important, some mechanics I made into tools, and how I reuse them in similar and different ways. Things are going to be pretty abstract throughout the talk. That's simply to keep us moving. This talk only has 20 minutes in real life and then a 10-minute QA session. But regardless of that, if you're watching this online, feel free to drop me a line. There's going to be contact info at the end of this video. I'm open to chatting on Discord or email if you have any specific questions about what I'm talking about. So what do I mean by reusable? I mean easily transferable and widely applicable. So you can quickly pull it from one game and put it into another, and that can also be used for quick and easy prototyping. And then conspecific is a similar game, and heterospecific is a different game. So like they're different uses, right? So they're not game specific. So a player controller that works in lots of different, like first-person shooter, third-person shooter, are real-time strategy games, etc. That's a very versatile player controller that we want. We also want our components to be aggregate, so procedural elements can be filled in a case-by-case basis. And code works together, but it also works on its own. And we'll talk more about that a little bit more in depth. And your code is holistic, so you define a global set of standards, and that is then understood by the player, and it's understood by you. And it's also understood by your IDE, right? So if you want the player to walk on surfaces, you shouldn't program it in a way that is against that. You should say, if there is a surface underneath the player, they can walk on it. And then as you go, maybe you want different types of surfaces that make them walk in different ways. Like you want them to run fast or be slippery on like ice or be slow in mud. And then in some cases, you might not want them to walk on surfaces at all. So, which leads me to the next thing here, which is make your code really malleable and serialize your variables. Like expose everything, make everything easy to see. But the biggest thing about making holistic code is that when something is expected to happen, it actually happens. We'll talk about that in a sec. But first, I want to talk about this. This is a programming concept, single responsibility principle. And it was made by Robert C. Martin. And it says, a module should be responsible to one and only one actor. The idea is that every aspect should be handled by its own class. So your scripts should be really specific, and if they are really specific and really segmented, they are extremely easy to transfer and reuse. And you can see two images here. I have a player, and the player has a controller, a weapon manager, stat manager, projectile manager, rage manager, generation seed manager, weapon pool, save data handler, movement ability manager, combat ability manager, currency manager, arena manager, and god feel manager. And each of those things operates on its own and can use each other. So it's a pretty malleable thing to change around depending on how I want to use it. And when elements are made up of aggregate components, it allows us to more easily manipulate them. Then I've also, then on the right, I've got two different things as well, and they're good examples of those elements sort of just being used on one thing. So there's a player camera controller. There's just one thing on it. It's not that crazy. And then same thing for the UI canvas. There's a UI manager there. And those elements alone can be moved around and shifted and changed in different ways. So we're going to talk about this concept as well, called a model view controller. And some of you who are more familiar with programming and software design kind of already know this, right? Like the user inputs something on the controller, the model calculates it, and then the view displays it. So in this case, we're going to be talking about a jump. So the player inputs a command to jump. They press space or A. The model then runs the command and fakes the jump. And by fakes, I mean runs an animation. So the player's not actually jumping. It just appears that they are jumping. And then the view is updated to represent that. So the player appears to jump on the screen. This is not holistic. There are lots of different examples that you can pull for this, but I think this is the easiest for game developers. If the player jumps, that jump should be simulated. It should not be run as an animation so that it appears that they are jumping. They really should be jumping, right? Their character jumping and not really jumping is something that I've come across a lot in earlier prototypes, both of myself and of my peers, and it drives me wild. And this is holistic. So if the player presses space to jump, the game actually simulates the jump, and it shows the player real information. It is accurate information, and the player can expect things in the world to operate on holistic principles. And as more and more holistic principles are built, the player's expectations will be met. And this not only helps you with building prototypes, but it also helps you with testing prototypes. Because if you make a puzzle system and every single puzzle needs to be set up manually, then sometimes those elements are going to fall through the cracks and you might miss some. In this case, by creating holistic things which work in the world and are simulated, everything is going to work according to a set of rules which you define. And prototyping with those rules and testing with players to get those rules down pat is going to be really easy because they will understand them. Yeah, so why make them holistic? Holistic elements operate by your standards. If things are really happening in your game, or as close to really happening, then it is easier to work with them. And if the player is fed immediate, accurate information in real time, they can predict your gameplay, they comprehend how your game works, and it also assists in debugging. I found this to be really useful, because when something is not working in a game, when you're building things not holistically, then it can be much harder to determine the problem. Whereas when you build them holistically, if the player is having trouble getting over an obstacle, it is more than likely because the simulated jump is just simply not jumping high enough, rather than the animation being finicky. So we're going to go through this first example. So this is a player controller I've been working on for about 4 years, and I'm pretty proud of it. This is what it looks like. You've already seen the screenshot up above. The below image on the right is a good example of kind of a good midpoint, I think, from about 2 years ago when I was working on this procedural kinematic body for it. But it is aggregate because all of the components of it work together, and it is holistic because it operates by your rules. It's holistic because it functions comprehensively in environments. If I put this player controller into any game, right, on the left you can see the first game I used it in 2019, and on the right you can see the most recent game. No matter what environment this controller is working in, it works holistically. Surfaces are surfaces, and there are jumps, and it can pick things up, and it can collide with things, and all this stuff, and it works, and it's holistic, and it I keep on saying the word, but it's just comprehensive. It understands the places that I'm putting it in, and the player understands the things it can and cannot do. And it's also not dependent on any other third-party assets or systems. Right, there are no rigid bodies on this controller. There's nothing to do here with any player controller assets. It's all stuff that I'm building and I've been modifying for my own purposes. Also aggregate because it's made up of all these specialized parts, right? And no code is codependent. Nothing is codependent. So if you look on the left, we have a camera, a body, an audio emitter, and that's about it. But on the right, we have 5 different cameras, I think 3 or 4 audio emitters, post-processing volumes, an inner body, and then an outer collider, which you can't see in this image, and then a whole animation rig. I think actually 2 animation rigs. That's a lot different. Here it is a little bit more in depth. So this is just the player controller, so one of the many scripts. We want to serialize all of our variables, so that way we can easily modify all of them and, watch them change in real time. We can see how they reflect changes in the game. We instance everything. So this is more for per script, but you want to create a static instance of every single script so that at any point you can quickly and easily grab any variable from any script that you need and just prototype with it. Now, this is a rule specifically for prototyping. I do not recommend instancing everything in your final game, but I do think that having these scripts be instanced allows you to very quickly access everything. And the only issue that this really raises is how much RAM do you want your game to use. But right now I have instanced every single one of my scripts, and my games have not run into any RAM problems. Definitely uses more than, games that do not do this, but for the sake of construction and prototyping, and especially working solo, it's really nice to have, and it allows you to do stuff. Like, I was able to make jump pads in one of these with one of these player controllers, and all it took was just me jumping the player, because I could just do that, right? Or, for example, if I wanted to make a gravity zone, I would simply create a trigger collider and then apply like a script that just basically grabs the player controller and says, okay, lower the gravity for a little bit. And as you make these modifications and add these things to the player, you should just leave them in, right? Leave those superfluous elements in, because even though in the current case of this player controller on the right, I'm not sprinting, I'm not slowing down while aiming, I am double jumping, but I'm not triple jumping, and I am using knockback, but even though I'm only using some of those things, you should leave them in, because as you're prototyping, you're going to want to add those things, right? Potentially. Maybe not, but who knows? You do want to have the option. So this is a little chart starting on the left in 2019 and ending on the right in 2022. And it's a lot of the games that I've worked on which have used this same player controller in so many different ways. On the left, we have the biggest project I worked on in my undergraduate degree, which is Illyrium. It's a first-person walking sim. I then took that and made 3 different kinds of player controllers. The first that I worked on was Monster Garden, which you can see at the bottom there, which kind of takes the player controller in there and really malforms it into this sort of third-person building sim camera. And recently I took that and turned it into Cell Rising's camera, which really should actually read 2022, not 2021. Going back to the far left, you can see at the very top, I created a series of third-person controllers out of the first-person camera controller, which ultimately resulted in going down to Godwalker. And in between, in the first-person area, you can see I did a little bit more of this first-person walking sim camera with Idiom, which was a game that I think every game designer makes, where you flip between two realms, two what are they, universes, whatever they're called, and you have to do platforming challenges. And then I made Relighter with my peer Matt, who is also at the Game Center, and we made this game about picking up wands and directing light throughout an island and bringing light back to the world, and it was really cute. And initially we were using Ben Esposito's first-person drifter, which sort of feels a little bit like Neon White, which I think is really funny. But eventually we were just like, I was just like, I'm going to drop in my own player controller briefly for this just so that I can use it. I think eventually we did actually go back to the other player controller, but there's some footage in there. You can just see that I kept on using it, and then eventually brought it into Godwalker as well. And continue from there. So this is a chart where I've sort of separated these. So there's con-specific uses, which are similar, and hetero-specific uses, which are entirely different. There's some weird stuff going on with this if you look at it based on content alone. On the left, we've got the 2 first-person walking sims, which are just the same controller again, and then we have our 2 third-person controllers. Now these third-person controllers have nothing to do with animation. The animation of this is entirely segmented. It's doesn't read anything from the controller at all, and it operates entirely on like momentum and player input, and it's its whole own thing. It doesn't read anything from the controller. The controller is just moving the body around, which I guess is dumb because that technically does mean that it is. But in hetero-specific uses, we've got Cell Rising and Monster Garden, which are obviously these very different third-person cameras and these prototypes where you're building things and moving tiles around and playing these completely different games. And then below those, we've got 2 games which have animation controllers, which take content and variables and read data directly from those player controllers. So that's why I've separated them, because, looking at Praetor in the bottom right, you can really tell that those animations are significantly different than Rockhoppers, even though those games were made back-to-back with the same controller. It's a very different procedural animation technique that I'm very proud of. Something I'm going to be talking about in my other talk as well. And after all of that, there's sort of this interspecific weird thing where I've got the animation controller from Praetor in the interspecific category in Godwalker. Then I've got the first-person movement and viewing from the original version of this controller in the same thing. And I thought that this was a really good way of looking at the species and sort of the genome, which is where all these conspecific, heterospecific, and interspecific terms are coming from. They're scientific terms to define like species and genomes. And this is all one genome is what we're looking at, basically. But that's just a way that I've been able to use all of these variables to do weird stuff with the same thing. So we're going to look at another example. So a prime wave function generator to make tile maps. This shouldn't be confused with wave function collapse. I also ran out of GIFs, so I hope you'll bear with me. But this tile generator, the way it works, it just drops a bunch of tiles down in an environment. You define how those things move together, and it creates a few paths and loops those paths around. And then it defines all of the walls around the edges of the tiles. Then it drops in walls in there and creates a flow of walls around it, so you can get all that information. So its functionality is predictable, right? We know how it works. It doesn't depend on anything else. And that makes it holistic. It's aggregate because it's made up of a series of specialized parts, and everything is modular, and nothing is dependent, right? We can customize it and do what we want with it. And we serialize everything, right? You can see on the right there's all this stuff, and if you look really closely, you'll see the word additorial, which is a word from a math blog that I found, and that is a whole nother rant. But there's a lot of variables in here that are pretty cool, and they make for some pretty neat generation. So we serialize everything, right? You can change all of these things and do anything you want with them. And that includes all of the tiles, right? Like we instance everything in here. So if we access this instance and change the tiles at runtime, then the generation is going to change. And we can specialize all of that. Then there's superfluous stuff too. You know, like what if we want ceilings or gaps, loops, height variations? There's a lot of things that I've never really taken out of this simply because it's so helpful to have, right? And it lets you generate these cool maps. So the things in the center are from Mindroid, which is a game I worked on in 2019, right around, and then went in and started my NYU degree. But it allows you to generate these really cool and fluid asteroids. You can see how I've replaced all of the modular elements with these models. That ends up looking like this, and it's really smooth. People in playtesting actually never noticed that I was using tile generation with this, which made me feel really good. That was my phone. One moment. Okay. But I was really satisfied with this. I was really happy with this. It made these really cool environments to explore. And here's the same chart again. It's a little bit smaller because, you know, we're not doing as much with it. There's not as much to show. I think you guys kind of get the point. It's a tile generator made to, you know, make these cool tiles that make cool asteroids and environments. That's how I was using it. In this case, the conspecific uses are tile generation of environments, right? Like Cell Rising has all these pretty colors and different types of blocks you can pick up and mesh around and make new blocks, and it has the highest point and the lowest point, and it collapses, or it doesn't collapse the wave. It uses prime, it's like a prime number function to distinguish what things are around it and what things it can place around it, and then it deciphers that from the wave and gets the highest and lowest points of the map. It does all this stuff, but it's basically the same thing as the Mindroid asteroids. But on the right, you have these heterospecific uses. They're totally different. Praetor and Godwalker had these shuffled environments with elements that would change each time you played, right? And that required a form of generation and a form of randomization that I was familiar with manipulating. So I was like, you know, I could use the same code to build these levels and mess around with these. And it works. I really like it. And it made me really happy because I didn't have to write all this other generation code. So you can see these two really neat test levels. The Praetor test level has all these rooms with lava in it and all these connected doors and secrets to find and all that cool stuff. And the Godwalker test level, this one was more interesting. This one just swapped out different types of weapons. And that's what I use the generation for, which at first may seem kind of weird. Like, why are you using a whole generation system for weapons? But it was a type of randomization which allowed me to, in the same way that Cell Rising has these dips and valleys and, you know, as you kind of walk, if you were to walk across that plane, you would get a variance in the things you are interacting with. I wanted to get that same kind of controlled variance in Godwalker's test level, just to see what would happen, which brings me to the interspecific, which is how I'm randomizing the levels that you encounter in Godwalker, the weapons you encounter, and the enemies you encounter, using the same kind of prime wave function that I'm using in the other environments to build and construct their levels. And I thought that was a really good example. So in summary, you should have aggregate component assembly, so build your things out of parts. You should holistically write your code so that it works in multiple places. You should instance all the scripts you need while you're prototyping. You should serialize everything so that you can read and interact with it, and leave your superfluous elements in. Thank you. So this is how you can reach me. Special thanks to Zach Anderson for letting me yell at him whenever I ran into problems with Delirium. I think that was very helpful. But yeah, that's all I've got for today. I hope to see some of you guys at WaffleCon 6. It was great seeing so many people at GDC. More people have asked me to make some more of these videos. I've got a few more talks that I will be doing in the future, so I actually will just create digital versions of those talks and upload them. But if you found this interesting and you wanted me to cover any other topics in game design that I might be familiar with, I'd be happy to take a stab at it. This one was a little bit more engineering related, but I'd be happy to discuss any other topics that people felt were interesting or they'd like more on. Or if you just have something that you feel like I've got a perspective on that you'd like to hear, I'd be down to do that too. Cool. All right. Well, if you have any questions, leave them in the comments. You can find me on Discord or just shoot me an email. So catch you guys later. Bye.